Hello everyone, myself Himanshu. Today we are going to discuss part test 11 regarding mathematics. So let us start the paper. Question number first. They have given us the circle. So equation of circle they have given is x square plus y square minus 4x plus 1 equal to 0. So regarding this equation we can say center is 2 comma 0 and radius is equals to square root of g square plus x square minus c, which is going to be square root of g square plus f square minus c, that is 4 plus 0 minus 1, so root 3 we get. Now what they are asking, they have given one more line, that is chord to the circle. So they are asking the length of chord. So if you draw the circle, you will have this as the circle. So assume this is the line that they have, which is 2x plus 3y minus 6 is equal to 0. We have to find the value of AB. This is given to be 2 comma 0. Let us assume this point is O. So if I draw a perpendicular here on the chord, so we know perpendicular on the chord will lie in the midpoint. This is M. So I can join these 2 points as well. So this is radius, and radius is root 3, just now we have seen. So if I can find the value of OM, we can get the value of AM by the Pythagoras theorem that we have. So we are finding the value of OM now. So OM, I can say it is going to be equals to 4 plus 0 minus 6 divided by square root of 4 plus 9, that is equals to 2 by root 13 that we will have, modulus we are going to have. And the value of radius, as we know, it is root 3. So AM we got, which is square root of radius 3 minus 4 by root 13. And if you simplify it, you get to know it is nothing more than root 35 by 13. So we got the value of AB, which is 2 times of AM, which equals to 140 by 13. Therefore, C is the correct answer that we got here. Okay, now let us move to the next question. Question number 2. They have given the line 3x plus 5y equal to k touches the ellipse. In the equation of ellipse is 16x square plus 25y square equal to 40. So if you have 16x square plus 25y square equal to 40, and this line 3x plus 5y equal to k. So I can say this is going to be tangent to ellipse. Which ellipse we have? 16x square plus 25y square equals to 400. Then only we can say it is going to touch the ellipse, no other case. So from here, I got the value of y, that is k minus 3x by 5. Just solve both of the equations. So you will get something like this. 16x square plus 25 times of k minus 3x by 5 whole square equals to 400. And this equation is going to be something like 25x square minus 6kx minus 400 plus k square equals to 0. This 5 I just cancel it out and simplify. Nothing else than that. Now, as it touches, so it means this equation, for this equation, d has to be equal to 0. Then only we can have both equal roots. So now we have to simplify for d equals to 0. So d means what? B square minus 4ac equals to 0. So this will say the value is 6k whole square minus 4 times of 25 into c is k square minus 400. This is equal to 0 that we get. So this is 36k square minus 100k square plus 100 into 400 equal to 0. So simplified, 64k square equals to 100 into 400. So from here we get k equals to plus minus 25. And that is the required answer that we will have. So C is the correct answer for second. Now let us move to question number 3. They have given that the line 3x plus 4y equals to root 7 touches the ellipse, then the point of contact. So if it touches the ellipse, it means they have given 3x plus 4y equals to minus root 7 is tangent to the ellipse, tangent to 3x square plus 4y square equal to 1. So now let us try to find the equation of tangent in point form regarding to ellipse. That is going to be 3x x1 plus 4y y1 equal to 1. Now regarding this equation is the tangent they have given. So we can compare both of the equations. So we get 3x1 by 3 equals to 4y1 by 4. This is equals to minus 1 by root 7, which will give us x1 comma y1 is going to be equals to minus 1 by root 7 comma 1 by, minus 1 by root 7. That we can find from here. So C is the correct answer for this question. So whenever they have said that touches the ellipse, or in the previous question also they have given the same condition. So it means they are talking about tangents. That's it. Nothing else than the tangent that we have. Okay. So now let us move to question number 4. Question number 4 they have given the tangent to the parabola y square equal to 4x at the point 1 comma 2 and 4 comma 4 meet at a line that we have to find. Okay. So first of all, parabola is y square equals to 4x. So equation of tangent to this parabola is going to be y1 equals to 2 times of x plus x1. So at 1 comma 2, we have the equation is 2y equals to 2 times of x plus 1, which we can say y equals to x plus 1. So this is the first equation that we will have. Now second equation what we can say is at 4 comma 4, so it is going to be 4y equals to 2 times of x plus 4. So it get cancelled out, so we get 2y equals to x plus 4. So if you simplify both the equations, you will get y equals to 3 and x is equal to 2. So that must be the point that we have. Regarding x, they mention x is equal to 3, so that is not the answer. So y equal to 3 that we have as the correct option. So C is the correct answer that we have for question number 4. Now let us move to question number 5. Here they have given normal to hyperbola xy equal to c square at a point t meets the curve again at t1. Then we have to find the value of t cube t1. What is the condition? Okay. So to solve this kind of question, we are going to take equation of normal in parametric form regarding hyperbola. So equation of normal is at point ct comma cyt is going to be equals to y minus ct t square times of x minus ct that we will get. Now as they have said this normal is going to meet again at a point t1, so it means t1 point must satisfy this equation of normal. Therefore let us satisfy that. So meet again at q, that is ct1 comma cyt1 that we have. So substitute this point in the equation, so you'll get c by t1 minus ct, this equals to t square ct1 minus ct. So this c we can take common from both the sides and cancel it out because c is a non-zero number that we have taken here. So after simplification, we get 1 by t1 minus 1 by t. This is equals to t square t1 minus t. So simplify it further. So you will get t square t1 minus t plus t1 minus t over t1 into t. This has to be equal to 0. Now we can take t1 minus t common from this equation. And we have other one is t square plus 1 by t into t1. That should be equal to 0. Now T1 can't be equal to T, because if T1 equals to T, then the same point we get again. But as they have mentioned, meet again at the point. So it means these two are different points. So this route is invalid for the time being. So we have to take the second route. So we get T cube into T1. This is equals to minus. Okay, now let us start question number 6. So in question number 6, they have given us 3 points A, B, and C. So let us take a triangle ABC. A is given to be 3, 4, B is given to be 0, 0, and C is given to be 3, 0. So we can just see the distances, that is 3, this is 5, and this is 4. Now they mention P is a point in the triangle such that this condition holds. So which condition is that? Distance of P from BC is less than equal to minimum of distance of P from AB and distance of P from AC. This condition they have mentioned. So regarding this condition, if you try to think a little bit, they are asking maximum of PBC. Maximum of PBC can be obtained. Max of PBC, distance between P and BC, can obtain whenever this PBC and distance between AB and distance between AC all are equal. So if all are equal means what? P is going to be nothing more than in center. So if P is in center, you have this point, let us assume P, that is in center. So assume the coordinates of P are h, k. You have to find this perpendicular distance as the distance they are talking about. So I can say BC is nothing more than x-axis. So this distance is going to be k. So y coordinate of P. Let us try to find y coordinate of P. That we can say it is going to be equal to 0 multiplied by 4 plus 0 multiplied by 5 plus 4 multiplied by 3 divided by 5 plus 4 plus 3, which is nothing more than 1, and that is our distance. Therefore, A is the correct answer. Here, which formula we have used? We have used AY1 plus BY2 plus CY3 over A plus B plus C, standard formula of our incenter that we have used here. Okay, now let us move to question number 7. In question number 7, they have given that T1 plus T by root 2 and 2 plus T by root 2 be any point on the line, then the range of values of T for which point P lies between these two parallel lines. Okay, so first parallel line is this one, second parallel line is this one. An equation of this line is given to be x plus 2y minus 1 equal to 0. An equation of this parallel line is x plus 2y minus 15 by 2 equals to 0. What they are asking to us? They are asking that this point, that is 1 plus t by root 2 and 2 plus t by root 2, this must lie in between the parallel lines. This condition they are asking to us. So if the point lies between the parallel lines, it means product. This product has, this is, let us assume L1, this is L2, this point is A. So L1A into L2A has to be less than 0. This condition we have to follow. So let us substitute them. So we will get 1 plus t by root 2 plus 4 times of 4 plus root 2t minus 1 multiplied by, I just substituted this point A in this equation. Now I am substituting this point A in this equation. So you will get 1 plus t by root 2 plus 4 plus t root 2 minus 15 by 2. This should be less than 0. This condition we will have. Now this 1 and 1 get cancelled out. And here also, if we simplify this completely, we will get 3t by root 2 plus 4, and here also 3t by root 2 minus 5 by 2 should be less than 0. Now assume 3t by root 2 is some x. So it has two roots according to this condition. One is 5 by 2, other one is minus 4. So plus minus plus using baby curve method. So we get 3t by root 2 lies in between minus 4 to 5 by 2. And if you simplify it, you get minus 4 root 2 by 3 t 5 root 2 by 6. So it means A option is correct that we will get. So whenever it is asked that the point lies between the lines, between two parallel lines. So one condition, the coefficient of x and coefficient of y should be same, and then use this problem property, and we will get the values. Okay. So now let us move to question number 8. In question number 8, they have mentioned ABC is an isosceles triangle. The point A is minus 1 comma 0, and angle AB, and AC, these things are given. So first let us draw the diagram. So assume this diagram we have. This is A, this is B, and this one is C. This angle is 2 pi by 3. These two sides are same, and they have given this coordinate is minus 1 comma 0, and BC is 4 root 3. As it is an isosceles triangle, so from this point, if I draw a median, it is going to go at the midpoint and perpendicular as well. This angle is 2 pi by 3, as it is mentioned already. So this is pi by 6, and this should also be pi by 6. So we get this distance is 2 root 3. Assume this point is D, that we will have. So now if this distance is 2 root 3, we are using the triangle A, D, and B. And what we are finding? We are finding the value of, actually we want to find the value of AB. If we get the value of AB, our work is done. We can get the point B from there, and angle we have already, as AB lies along x-axis. So angle also we can find. So let us try to simplify. So we are finding cos pi by 6. So cos pi by 6, I can say it is going to be equals to, that we have here, BD by AB, this one by this, because this is known as base in this triangle, and this is our hypotenuse that we will have. So the value of cos pi by 6 we know already, cos 30 degree, it is going to be root 3 by 2, and BD is 2 root 3 by AB. This will imply AB is going to be equal to 4. So if AB is 4 and AB lies along x-axis as well, so we can say coordinate of B are going to be 3 comma 0. And as this is the x-axis, this angle will become 5 pi by 6. So we get equation of BC as 5 minus 0 equals to 10 5 pi by 6 into x minus 3. This is the equation of BC we will have. Simplify it. So you'll get y equals to minus 1 by root 3 x minus 3, which implies x plus root 3y equal to 3. So we have x plus root 3y equal to 3. So A must be the answer regarding question number 8. Okay. Now let us move to question number 9. In question number 9, they have given us the coordinate axes are rotated about the origin. So rotation of axis is happening here in counterclockwise, or we can say in anti-clockwise direction. At an angle of 60 degrees, P and Q are the intercept made by the new axis on the straight line, whose equation is referred in the original axis, x plus y equal to 1. This is original axis that we will have. Now we have to find this value, 1 by p square plus 1 by q square. Now think of it. If axis is rotated about origin in anti-clockwise direction, then old coordinates and new coordinates have a relation. So let us write that relation. That old coordinates are x comma y, and new coordinates are x dash comma y dash. So we have the relation x is equal to x dash cos 60 degrees as the rotation is happening with respect to 60 degrees minus y dash sin 60 degrees and y equals to x sin 60 degrees plus x dash y dash cos 60 degrees. So this will imply x is equal to x dash minus root 3 y dash by 2 and y we can find easily. Y is equal to root 3x plus x dash plus y dash by 2. These two values we will have. Now, if you satisfy these two equations in our original equation of straight line, we will get x dash minus root 3 y dash plus root 3 y dash plus root 3 x dash plus y dash. This has to be equal to 2. This one we get. And if you simplify further, you get root 3 plus 1 x dash plus 1 minus root 3 y dash equals to 2. Now, as we know, the intercept form of a line is x by a plus y by b equal to 1. This is the intercept form of a line. So with respect to this, we can say the value of p is going to be 2 by root 3 plus 1 and the value of q is going to be 2 by 1 minus root 3. These things we will have. So 1 by p square plus 1 by q square, it is root 3 plus 1 whole square plus 1 minus root 3 whole square by 4, which is nothing more than 3 plus 1 plus 2 root 3, 3 plus 1 minus 2 root 3 by 4. These things get cancelled out. So you will get 2 as the correct answer that we will have. So it means ninth correct answer is 2. Okay, now let us move to next question. That is question number 10. So in question number 10, the equation of straight line equally inclined to the coordinate axis and equidistant from these things is what? This is what they have asked. So if this straight line is equally inclined, so we have two kind of format. Either the slope can be plus 1 or the slope can be minus 1. So it means equation of line is y equals to x plus c or y equals to minus x plus c. These two cases we will have. So let us take the first case, y equal to x plus c. And as the distance from minus 1 comma minus 2 and 3 comma 4 is equal, so try to utilize that condition. So we are taking the first case, y equals to x plus c. So check the distance. So the distance is going to be equals to minus 2 minus 1 plus c by root 2. This is equals to y, that is 4 minus 3 plus c by root 2. Root 2 and root 2 get cancelled out. So you'll get c minus 3 modulus. This is equals to 1 plus c. Simplify both of them. Then if you are going to simplify, you will get c minus 3 equals to minus 1 minus c. You cannot open with respect to c minus 1 equal to c plus 1. I mean c minus 3 equal to c plus 1 because c and c get cancelled out in that case. So from here we get 2 times of c equal to 2. So c equals to 1. So we get the equation of line, that is y equals to x plus 1. So this one we can satisfy. D is the correct answer. So we do not have to take care of this case. We got our required answer in this part. Now let us move to the next question. We have to find length of lattice rectum to the ellipse. So first of all, write this ellipse in standard format. So we have 3 times of x minus 1 whole square plus y minus 1 whole square equals to 9, which we can say x minus 1 whole square by 3 plus y minus 1 whole square by 9 equal to 1. So a square equals to 3 and b square equals to 9. Therefore, length of lattice rectum, this is equal to 2 times of a square by b, which is 2 into 3 by 3. So 2 must be the answer that we will get. I hope this is clear to everyone. So now let us move to the next question. Question number 12. They have given focal chord of a parabola y square equals to 4ax. Meet at P and Q. So S be the focus. We have to find 1 by SP plus 1 by SQ. So assume this is the parabola that we have. Oh, sorry. This is the parabola. This is our x-axis. So there is a line like this. This point is given to be a comma 0 as focus. P and Q points. So we can take the P point to be parametric form 8t1 square comma 2at1 and 8t2 square comma 2at2. They are asking sp1 and sp2. So let us find those values first of all. So sp we can say it is square root of 8t1 square minus a to the whole square plus 2at1 perfect square. If you simplify it, it is going to be a times of t1 square plus 1. Similarly, sq will be equals to a times of t2 square plus 1. So what is 1 by sp plus 1 by sq? This will be equal to 1 by a, 1 by t1 square plus 1 by t2 square plus 1. Now, as this code passes through focus, so we know the condition that t1, t2 equals to minus 1. So we can use this one. So just replace the value of t2 as minus 1 by t1. So we will get this is 1 by a, 1 by t1 square plus 1 plus t1 square divided by 1 plus t1 square, which is equals to 1 by a. Therefore, B is the correct answer that we will have regarding question number 12. Question number 13. So in question number 13, they have given normal to hyperbola meet the coordinate axis at x and y, coordinate axis x and y at A and B, and some parallelograms there. So equation of hyperbola is x square by 9 minus y square by 4. This is equal to 1. So let us write the equation of normal in parametric form. So equation of normal we get is ax cos theta plus by cot theta. This is equals to a square plus b square. So value of a is 3 and value of b is 2. So which we can say 3x cos theta plus 2y sin cot theta equals to 30. So it implies the coordinate a is going to be 13 by 3 cos theta comma 0 and the coordinate b is going to be 0 comma 13 by 2 tan theta. These things we will get. Now let us draw the parallelogram that they have asked. So regarding this parallelogram, this is origin 0 comma 0. This point is A, 13 by 3 sec theta. This is sec theta, not cos theta. This is B, 0 comma 13 by 2 tan theta. And this point is P that we have to find. Assume it is x comma y. So as it is a parallelogram, we know the property that coordinates of A plus P are going to be equal to origin plus P, x coordinate and y coordinate. So use it. So we can write x plus 13 by 3 sec theta equal to 0, which will imply that x is equal to minus 13 by 3 sec theta and 3x is equal to minus 13 sec theta. Similarly, we get y equals to 13 by 2 tan theta, which says 2y equal to 13 tan theta. Now we can use the property sec square theta minus tan square theta equal to 1. So we get 3x whole square minus 2y whole square. This is equals to 169. So we have the answer 9x square minus 4y square equals to 169. D is the correct answer. Okay, now let us move to the next question that we will have question number 14. So in 14, they have given L1 be the length of common chord of the curve x square plus y square equals to 9 and y square equals to 8x. So if they have given common chord, so first let us try to find point of intersections regarding these two curves. So simplifying it, x square plus 8x minus 9 equal to 0. This will imply x can be equal to 1 and minus 9. We cannot take x as minus 9 because in this case y square equals to minus 72, which is not possible. Therefore, we are taking only x is equal to 1. So if x is equal to 1, y square equals to 8. So we have the point 1 comma 2 root 2 and 1 comma minus 2 root 2. Therefore, L1 is 4 root 2. Second thing, let us reckon is 4 times of A, which is given to be 8. That is L2. So clearly we can say that L2 is greater than L1. A must be the correct answer that we will have here. So let's move to question number 15. In question number 15, they have given three concentric circles. Which of the biggest is this one? X square plus y square equal to 1. Have their radius is in AP, and this line cuts all the three circles at real and distinct points, the interval in which the common difference of AP lies. This is what we have to find. So assume we have these concentric circles. This is first, x square plus y square equal to 1. Second must lie somewhere here. And this is our third circle. So this is x square plus y square equal to 1. This let us assume x square plus y square equal to 1 minus d whole square as the radius are in AP. And third is x square plus y square equals to 1 minus 2d whole square. These things we will have. Now there exists a line that is y equals to x plus 1. It will cut all these three at real and distinct points. So it means line has to go like this, and at maximum it is going to touch this inner circle. So it becomes a tangent. This is the maximum value that we can have. So the origin is the center of all these three circles. So regarding this circle, x square plus y square equals to 1 minus 2d whole square, we know this line y equals to x plus 1 can maximum be the tangent. It cannot be like this line is outside the circle. This condition we cannot afford. So it means distance from origin to this line y equal to x plus 1 can maximum be 1 minus 2d. So this will imply distance from origin to y minus x minus 1 equal to 0 can max be 1 minus 2d. So this will say, just find the distance that we have. 1 by root 2, perpendicular distance I have found, is less than 1 minus 2d. So simplify it. So you will get 1 minus 2d equal to also we can take because it can be the tangent as well. So 1 minus 2d. Okay, one second. They have not given tangent. They have given real and distinct. So equality won't come. It has to be strictly less than. You cannot take less than. So this has to be greater than 1 by root 2 we get. So we get 2d should be less than 1 minus 1 by root 2. So d is less than root 2 minus 1 by 2 root. So if d is less than this thing, d has to be greater than 0 also. So it is greater than 0. So which option do we have? We have C option. If you multiply it by root 2, you will get 2 minus root 2 by 4. That is mentioned in the C that we have. Okay. Now let us move to the next question. Question number 16. They have given the director circle regarding this touches the circle, this one, then the value of R. As we know, director circle regarding parabola is directrix itself. So the equation of directrix is going to be x is equal to minus 11 because the point is minus 7 comma 2, that is the vertex that we have, and the focus that a value is 4, so it is going to go behind 4 units, so we get minus 11. So if this is the directrix, then distance from, so this is directrix, this touches this circle, so it means this directrix is tangent to the circle. So if directrix is tangent to the circle, this one, x plus x minus 1 whole square, y plus 1 whole square equals to r square. So we have to find the value of r. So if you have a circle like this, there is a tangent. So this perpendicular distance has to be the radius. And this is what we are going to find here. So if you are finding the perpendicular distance, that is going to be r. Perpendicular distance is nothing more than the point is 1 comma minus 1. So we can say 1 plus 11 by 1, which is 12. That will be the radius that we have here. Okay, now let us move to the next question. That is question number 17. In question number 17, they have given radical center of three circles is origin. So it means 0, comma 0 is radical center. Two equations of circles are given to us. Then third equation of circle passes through these 2 points and radius can be expressed in the form of P by Q. We have to find P and Q. In this condition they are asking. Okay. So here we are going to use equation of family of circles. So circle which is passing through these 2 points can be written as x minus 1. Which formula we are using? We are using this one, x minus x1, x minus x2 plus y minus y1, y minus y2 plus lambda times of x y1, x1 y1 1, x2 y2 1. This is equal to 0. So simplify it. So we have x minus 1, x plus 2 plus y minus 1 whole square plus lambda times of x, y and 1. This will become 1 1 0 minus 2 1 1. Oh, sorry, this is 1. Now if you are, this is equal to 0. If you are going to simplify this one, then you are going to get some constant times of y minus 1 that we will have. I hope you can simplify this determinant easily. So this condition will say x minus 1, x plus 2 plus y minus 1 whole square plus lambda times of y minus 1 equal to 0. I am not writing k because lambda is also a constant. So writing two constant does not make any sense. So this is our, let us assume, circle that is S2. And one circle is given to be S1. So radical axis we can find S1 minus S2. So which is going to be x square plus y square minus 1 minus x square. This is plus 2x minus x, so plus x minus 2 plus y square minus 2x plus 1 minus lambda times of y minus 1 should be equal to 0. Now you can say x square and y square get vanish out. Yes, this minus 2 get cancelled out with this plus 1 and this outside one. So we get the condition from here, that is minus x, it is 2y, plus 2y minus lambda times of y minus 1 should be equal to 0. Now, as this is radical axis, it has to pass through radical center. So if it is going to pass through radical center, we get the condition as lambda equal to 0. As this 1 passes through 0, 0. Therefore, circle equation is x minus 1 whole square, x plus 2 whole square plus y minus 1 whole square equal to 0. This is our equation of the circle that we have. So if this is the equation of circle, radius is going to be 3 by 2. So we get P equals to 3, Q equals to 2, and we can find P plus Q, that is 5, that we will have. Okay, now let us move to the next question, question number 18. They have given coordinates of foci of the ellipse we have to find. Okay, so in this ellipse, they have mentioned the value of a square and b square. A square is 9 and b square is 16. So we know e square minus 1 is b square by a square in this, sorry, not ellipse, hyperbola. This condition we know. So we can write this is going to be 16 by 9. So we have e square is 25 by 9. So we get the value of e as 5 by 3. We cannot take minus 5 by 3 because eccentricity is not negative. So foci is going to be 1 plus 3e comma 2 and 1 minus 3e comma 2, which is 1 plus 3e means 1 plus 3 into 5 by 3 comma 2 and 1 minus 3 into 5 by 3 comma 2. You get cancel out these things. So we will get the output answer as 6 comma 2 and minus 4 comma 2. 6 comma 2 and minus 4. So C must be the correct answer that we will have here regarding question number 18. Okay, now let us move to question number 19. In question number 19, the eccentricity of hyperbola is root 5 times of eccentricity of this ellipse. Then we have to find the value of alpha. Okay, let us try to find. So first equation, hyperbola is given to be x square by 25 minus y square by 25 sine square alpha equal to 1, and ellipse is given to be x square by 5 sine square alpha plus y square by 5 equal to 1. So let us find the eccentricity regarding the hyperbola. So if you are finding eccentricity regarding this, E will become square root of 1 plus sine square alpha. And here eccentricity will become, this is E1, let us assume this is E2, 1 minus sine square alpha. We are using the same formulas. For hyperbola, we have square root of 1 plus b square by b square by a square. For ellipse, we have 1 minus b square by a square. Those conditions we are using here. So now we got these two conditions. They have said this E2, they have said the condition eccentricity of hyperbola is root 5 times of eccentricity of ellipse. So it means E1 equals to root 5 times of E2, which will say 1 minus 1 plus sine square alpha equals to 5 minus 5 sine square alpha. So we get 6 sine square alpha equals to 4. So sine square alpha 2 by 3. So sine alpha we got root over 2 by 3. But they did not give any option like this. So let us check in tan inverse. So if you have this triangle, this is alpha, this is 2, root 2 and this is root 3. So this has to be 1. So this can be written as tan alpha equal to root 2. So we get alpha is tan inverse root 2 that we will get. So A must be the correct answer regarding this question. Let us see question number 20. In question number 20, they have given an ellipse. So let us assume this is the ellipse that we will have. This is our major axis. Here we have minor axis. And we have a tangent like this. One ellipse, this foci is S, other one is S1. And we are drawing fit of perpendicular from these two foci. So first one will become pi, second one will become this one, that is pi1. So as we know, SPI into S1 pi1 is nothing more than b square. So you are using summation 10 number of times. So it means 10 times of b square will be equals to 2560. This will get cancelled out. So we get b square is 256. And they have given the length of semi-major axis is 20. So it means they have given the value of a square is 400. So e square is equal to 1 minus b square by a square. Just substitute these values. So you'll get 1 minus 256 by 400, that is 144 by 400. So E value is 12 by 20, which you can cancel it out and you will get 3 by 5. This must be the correct answer that we have. C, 3 by 5. Now let us try to solve the next one. That is question number 21. So in question number 21, they have given for how many integral values of m these two equations intersect at integral coordinates. So if they are intersecting at integral coordinates, so it means first equation is 3y plus 3mx minus 3 equal to 0. Instead of that, multiplied by 4 to cancel it out. So first one is 3x plus 4y equals to 9. And second one equation they have given to us is 4y plus 4mx equals to 4. So subtract these two equations. So if you are going to subtract, you will get 3x minus 4mx is equal to 5. This condition we will get. And from here we can find the value of x easily. That is x is equal to 5 by 3 minus 4m. So integral coordinates means what? X and y both should be integral. Both should be integers. So if both are integers, x is also has to be integer. So if x has to be integer, integral values. So we cannot take m to be a negative number because if you will take m is equal to, let us assume, minus 1. So denominator will be greater than numerator. Those conditions are not permissible. So we can take m equal to 1 and m equal to 2 in this case. Because if you'll take m equal to 1, x is going to be equal to minus 1. And for m equal to 2, x is going to be equal to, that we have minus m equals to 2 we have taken. So x is equal to minus 5 in the first case, sorry. If you have taken m equal to 1, then x is equal to minus 5 we will have. And for m equals to 2, it becomes x is equal to minus 1. So if we have integer values of x, we can find integer values of y easily by this equation as it says. So we have only two integral values. Okay, next one, question number 22. In question number 22, the radius of the circle having normals, these 2 points, also have tangent, this one is k. So if these two are the normals of the circle, we know normal passes through center. Therefore, center is given to be 2 comma 6. And as this is the tangent, so we have this case. This is the circle that we will have. And we are having a tangent here. This is center, 2 comma 6. This is 2x plus 5y minus 5 equal to 0. We have to find perpendicular distance from this point to this tangent. So perpendicular distance is, just substitute this point, you will get 4 plus 30 minus 5 by square root of 4 plus 25, which is root 29. So we will get the value as 29 because they are asking k square value. Now let us move to the next one. So in this one, they have given from the point minus 1 comma 2, Tangent lines are drawn to this one. If the area of triangle formed by chord of contact and the tangent, then we have to find the value of lambda, something like this. So let us try to solve. First of all, if you are having a parabola in this way and you have drawn two tangents from this point and assume this coordinate is 81 comma 81 square comma 281 and sorry 281 comma 81 square, sorry about that, 81 square comma 281 and this is 82 square comma 282. Then this point has to be equals to a times of t1 t2 comma a times of t1 plus t2. These two things we will have. So we get t1 t2 is equal to minus 1 and t1 plus t2 this is equals to 2. So from here we can find mod of t1 minus t2 as well, which is square root of t1 plus t2 whole square minus 4 t1 t2, which is square root of 8. These conditions we will get. So area of triangle is half times of modulus of t1 square 2t1 and 1 t2 square 2t2 and 1 minus 1 2 and 1. We haven't taken a here because the value of a is given to be 1. So there is no point of taking that. Just simplify this determinant. So if you are going to simplify this determinant, you will get the output answer as t1 t2 t1 minus t2 minus t1 minus t2 into t1 plus t2 minus t1 minus t2, and which is going to be equal to minus root 8 minus 2 times of root 8 and minus root 8, which we can say minus 4 times of root 8. And as modulus is there, we will get it is root 8 can be written as 2 root 2, 8 root 2. So the value of lambda is 8 that we have from here. Now let us move to the next question, that is question number 24. So in question number 24, common tangent they have asked regarding these two circles. So first circle coordinate center 1 is 0 comma 0 and radius is 2. Center 2 is 3 comma 4 and radius is 7. So C1 C2 we can find it is 5, and here we can easily see that C1 C2 is equals to mod of this is R1 R2 R2 minus R1. Therefore we have only one tangent because this case one circle is inside the other circle. This kind of condition we will have. This is one circle and second circle should be something like this. It is touching from inside. So this is C1, this is C2. C1, C2 should be equal to R1 minus R2 modulus. Therefore, only one tangent is possible that passes through this point. Okay, now let us move to the next question. That is question number 25. So in question number 25, they have given minimum area of the triangle formed by the tangents of the ellipse. So the ellipse is x square by b square plus y square by 4a square equal to 1. And the coordinate axis is KAB. So first of all, equation of tangent is we can find that is going to be x cos theta by b plus y sin theta by 2a. This is equal to 1. So if I have an ellipse like this, assume, and this is our major axis, here it is our minor axis, and this line is passing through like this. First point, second point. So you can find the point A, put y equal to 0. So if you put y equal to 0, you will get b by cos theta. comma 0. And here if you substitute x is equal to 0, you will get 0 comma 2a by sine theta. This is O, A, and B. So area of triangle will be equal to what? Half times of B by cos theta into 2a by sine theta, which is 2ab by sine 2 theta. So maximum value of area of triangle is 2ab when sine 2 theta is equal to 1. Sorry, minimum value of this one is 2ab when sine 2 theta is equal to 1. That is the maximum value of sine 2 theta that we got. Therefore, the value of k has to be equal to 2.